In section 6.4, we are going to work on converting between radical form and exponent form. So what we have over here is in radical form. You can tell it's in radical form because it has the radical symbol. And then what we have over here is in exponent form, and it does not have a radical. It has a base, and then this one has a fractional exponent. So you can probably already tell by the color coding system here that this B and this B are both purple. They all have special names. This one's name is the radicand. It's the thing that is inside the radical. When it's in exponent form, it's called the base. So whatever the radicand is becomes the base when it's in exponent form. And we can convert these back and forth. So if we have a base in exponent form, it becomes the radicand in radical form. Sometimes the radicand has a power right here. That is the power on the radicand. And notice that it is the same color as this right here, which is the numerator of the exponent. So these two things are equivalent. So to change from radical form to exponent form, the power that's on the radicand becomes the numerator of the exponent in exponent form. And then we have this letter C here. This is called the index of the radical. And the index of the radical is going to become the denominator of the exponent, and vice versa. So if I'm changing from radical form to exponent form, the index of the radical becomes the denominator of the exponent. If I'm changing from exponent to radical form, the denominator of the exponent becomes the index of the radical. So we can switch back and forth between radical and exponent form using these guidelines. So let's practice some examples. So if it's in radical form, we're going to switch it to exponent form. If it's in exponent form, we're going to switch it to radical form. So we'll just be doing several examples here. So these will just be kind of rapid fire examples using these guidelines. So this first one here is in radical form right now. So I'm going to change it to exponent form. So that means I'm going to take the radicand right here, which is 13. It's going to become, the radicand becomes the base. So that's going to be 13, and it's going to be raised to some power. Well, it's going to be a fractional power. Remember, the numerator of the exponent is the power on the radicand. So what power do we have on this 13? If there's not one written, we assume it to be a 1. So the numerator will be a 1. The denominator of the exponent comes from the index of the radical. So I look in the index of the radical here, and there's no number there written, which means it's a square root. So the index is 2. So this would be 13 to the 1/2 power. Moving over to this one on the right, now I have a cube root of 13. So kind of, it's a parallel problem, just has a different index. So the base is going to be a 13. And then in my exponent, remember the numerator comes from the power, which will be also a 1. The denominator comes from the index, which in this case is a 3. So that would be 13 to the 1/3 power. How about the 5th root of 13 squared? The radicand is that 13, so that's going to become my base. And then in the exponent, the power on the radicand is 2, so that's my numerator. The index is 5, that's my denominator. So 13 to the 2/5 power. Now we get to switch. This is in exponent form, and we're going to make it into a radical. So I know I'm going to need a radical symbol. I'm going to take my base and it becomes the radicand. So the x is going to go inside. Looking at my exponent up here, the numerator of the exponent is going to become the power on the radicand. So the 5 stays onto the x here. So x to the 5th is inside. The denominator of the exponent becomes the index of the radical. So that will be a 3. So I have the cube root of x to the 5th. Now this one looks kind of similar, but also kind of different. The difference here is that instead of x to the 5/3, I have the 5/3 is attached to a parenthesis. So when I change this into radical form, whatever the exponent is attached to in exponent form is going to become the radicand. So since my exponent in this problem is attached to that parenthesis, the parenthesis becomes my radicand. So the parenthesis 2x is the radicand. Remember, the numerator becomes the power, so that's going to be to the 5th power, and the denominator becomes the index. So I have the cube root of 2x in parentheses to the 5th power. Now this one looks similar, but different. This 5/3 power on the second problem over here is attached to the x, not to the parenthesis. So remember that the only thing that's going to become the radicand is whatever the exponent is directly attached to. So the 5/3 is attached to the x, but then it's multiplied by the 2, because if two things are sitting next to each other, they're multiplied. So 2 and then times x to the 5/3. So I'll put my x inside my radical. Remember, the numerator becomes the power on the radicand, and the denominator becomes the index of the radical. So now I've made this part into radical form. What do I do with that 2? Since it's 2 times the exponent form, I'm going to keep it 2 times the radical form. So it will just stay out front like that. Okay, now let's look at some more complicated problems. How about the cube root of x squared minus x cubed? So we're obviously going to be switching this into exponent form. So I need to know what is my radicand and then what is the power on the radicand. So all of these problems up here only had one term inside the radical. This one has 2 terms inside the radical. So when you have 2 terms, meaning that you have either addition or subtraction, those cannot be separated using a square root. So this whole expression, x squared minus x cubed, this whole expression is the radicand. So that whole expression becomes the base. So x squared minus x cubed becomes my base. And then I need a fractional exponent up here. So I need to know what is the numerator. The numerator comes from the power on my radicand. So what is this x squared minus x cubed raised to? Remember, if there's no power there, it's assumed to be a 1. So this is going to be to the 1 because of the power there. And then the denominator comes from the index of the radical. So it'll be to the 1/3 power. Let's see if we can work a problem backwards now. 7t to the 5/2. This is in exponent form, so we're going to change it into radical form. Whatever the base is going to become the radicand. So the base is whatever the exponent is attached to. It's attached to that whole parenthesis. So the whole parenthesis 7t is the radicand. The numerator will become the power on the radicand. So that will be to the 5th power. The denominator becomes the index of the radical. And since that's a 2, which means it's a square root, we do not write that. So we'll just leave it square root of the quantity 7t to the 5th. Now, these parentheses are important in here because this is telling me that the 7 is to the 5th power and the t is to the 5th power. If I didn't have parentheses, like this problem had parentheses, this one did not. If you have parentheses, then both of those parts go into the radicand. If you don't have parentheses, then the 2 stays out front and only the x goes in. So it's very important to pay attention to the details of what is going on. Oh, this will be an easy one. Did you get it? The radicand is the 2x in parentheses, the power is 5, and the index is 4. Let's try in reverse. How about 7t to the 5th inside that radicand? Okay, in this problem, remember the radicand becomes the base. So this whole thing is the base. 7t to the 5th is the base. Now, in order to show that 7t to the 5th is the base, what I need to do is put it inside a pair of parentheses to show that the exponent is going to go to the 7 and the t to the 5th. If I don't put it in parentheses, then it would be like my problem started out with the 7 outside. So be careful with that. What will the numerator of this exponent be? Well, what power is 7t to the 5th raised to inside there? It's to the first power. So this will be 7t to the 5th to the 1, and then the index here becomes the denominator, so the 1/2 power. Now, if you wanted to get fancy, remember when you raise a product to a power, you give that power to both of the factors, both of the bases. So you could write this 7 to the 1/2 times t to the, multiply those powers, 5/2. What's next? Let's do this one. 2 times the 7th root of 5t. Getting more complicated as we go. So the first thing I want to do is change this into exponent form. So what is my base going to be? The base is going to be the radicand of 5t. So I'm going to have 5t. And then what power will that be raised to? Well, it's going to be the power on the radicand over the index of the radical. So that will be 1 over 7. And then when I have that 2 out front, I'm still going to have times 2 out front of there. Okay, on to the next set of instructions. What we're going to be doing is we're going to be simplifying and evaluating. So simplify / evaluate. Those kind of mean the same things. And what we're going to do is we're going to give our answers in radical form. So with each problem, I'm going to give you some helpful hints to help you get it started, and then we'll work through. They all kind of have their own special characteristics that we'll talk about. So here we have 512 to the 1/3. So what I'm going to have you do on this problem is we're going to start by rewriting in radical form. So the base of 512 becomes the index of the radical. The power on the 512 is 1, so I'm just not going to write it. And the index of the radical is 3. Then I'm going to simplify the cube root of 512. So remember, in simplifying radicals, that means I'm going to break down my 512 using a factor tree. So I'll help you out here. That is 8 times 64. And then 8 breaks down to 4 times 2. 64 breaks down to 8 times 8. Keep going on this 8. 4 would be 2 times 2. I'm going to keep bringing that 2 down. So I can kind of take a shortcut here because I already know that 8 breaks down into 2 times 2 times 2. So I'm just going to make these go faster. 2 times 2 times 2. And this 8 also is 2 times 2 times 2. So at the bottom of my row here, 512 is equal to 2 to what power? 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 to the 9th power. So I'll rewrite this as the cube root of 2 to the 9th power. And then remember that this index tells me how many have to be in my group to get out. So I have to have 3 in a group to get out. I have 9 2s, which means I'm going to have 3 groups of 2 that get to get out front of the radical. So I'm going to have how many groups of 2? 3 groups of 2. And if all 3 groups of 2 come out, there will be none left in, so I don't need a radical anymore. So that would be 2 to the 3rd power, which is 8. So that would be my answer. And it doesn't need to be in radical form because there's nothing left in the radical. More examples. Let's see. Cube root of a times square root of a. Now this one is kind of a tricky one. What I'm going to have you do is rewrite in exponent form. So now we're going to have a multiplication problem. This first one is going to have a base of a, and the exponent is going to be the power over the radical. So a to the 1/3. And then times, this one has a power of 1, and remember an index of 2, so times a to the 1/2. Now we have a multiplication problem. Remember that when you multiply bases with the same base, when you multiply bases, what do we do with the exponents? When you multiply bases, you're going to add the exponents. So now I have a to the, I'm going to do 1/3 plus 1/2. And remember, to add fractions, I need a common denominator. So I'll do this one times 2. So I get 2/6, and this one times 3 plus 3/6, which would be 5/6. So now I have a to the 5/6. And then remember, my instructions said that I should rewrite this in radical form, rather. They want it to be in radical form. So I'm going to have a radical symbol. My radicand is going to be the base of a, and then the numerator of the exponent becomes the power on the radicand. The denominator of the exponent becomes the index of the radical. So this answer would be the 6th root of a to the 5th power. Let's do another. How about the 4th root of a cubed divided by the square root of a? I think you might know what I'm going to have you do is change this to exponent form. So the radicand in the numerator was a, so a, and then make that a fractional exponent. The numerator is the power on the radicand. The denominator is the index of the radical, so a to the 3/4. And then the denominator has a radicand of a. The power is 1, the index is 2, so it's a to the 1/2. Now remember, when you divide bases, what do we do with the exponents? Well, when we multiplied them, we added them. So when we divide, we subtract them. So I am going to do 3/4 subtract 1/2. And since I started with the numerator in my subtraction problem, I did not mean to write that. Since I started with my numerator on the subtraction problem, my answer is going to go in the numerator instead of the denominator. So 3/4 minus 1/2, need a common denominator. So that's 3/4 minus 2/4, which is 1/4. So a to the 3/4 over a to the 1/2 is equivalent to a to the 1/4. And then they wanted it in radical form. So I'm going to have a radical. The base becomes the radicand. The numerator is the power on the radicand, which is a 1, so I don't write it. The denominator is the index of the radical. So this is the 4th root of a. Okay, let's look at this one. You can probably guess that we are going to write this into radical form. If we write this into radical form, then that is going to be the radicand is m to the sixth. The index of the radical is a 3. And then what I'm going to have you do is I'm going to have you take this 2 and put it all the way on the outside. Now, you could have done that the traditional way that we've been doing them. You could have done cube root of m to the sixth and then raised to the 2 power. It's up to you. I will show you how to do both ways. I think this way is easier. So then what we're going to do is simplify the radical. So I have the cube root of m to the sixth. Cube root means 3 in your group to get out. I have 6 m's, which means I can get out 2 groups of m's. So now I have m squared to the second power. And then when you raise a power to a power, you multiply. So this would be m to the fourth. Now, if we had gone this route, we would do m to the sixth squared first. So since I'm raising a power to a power, I will multiply the exponents. So that will be m to the 12th. And then simplify the radical. 3 in the group to get out, I have 12, which means I will get out 4 groups. So either way, I got the same answer. Now there's a third way that you could do this problem. And that's just by multiplying these exponents from the beginning, but that's not always going to get you to a good final answer. So I'm going to have us stick to one of these 2 methods so that we have a more general strategy that will work for more problems. Okay, here's another one that's of this type. 216x cubed to the negative 2/3 power. We've seen this with a negative attached to a parentheses before. So remember the strategy there was to flip what's inside the parenthesis and make it positive exponent. So that is going to be, instead of 216x cubed, it's really 216 over 1. So it's going to be 1 over 216x cubed to the positive 2/3. And then I'm going to rewrite that in radical form. So I'm going to have what kind of radical? Well, the denominator tells me the index, so it's going to be a cube root of 1 over 216x cubed. And then we've got to deal with this power. So remember, I had told you that I feel like it's easiest to make the power outside the whole problem. So this 2 became outside that whole problem. And then I'm going to work inside the parentheses. So remember, when we have a fraction inside a radical, we like to think of it, or at least I do, as the cube root of 1 over the cube root of 216x cubed. The cube root of 1 and the square root of 1 have the same answer. They are just 1. So the cube root of 1 becomes a 1. And then when I have a number inside my radical, what I do is I break that number down. So I'm going to break that 216 down. It happens to be 4 times 54. I'm going to keep going. 4 is 2 times 2. 54 could be 9 times 6. Keep going. Bring those 2's along. 9 is 3 times 3. And 6 is 3 times 2. So 216 would be the same thing as 2 to the 3rd power times 3 to the third power. So now I have cube root of 2 to the third power times 3 to the third power times x to the third power. And now I will simplify inside my radical. I have a cube root, which means I need 3 in my group to get out. So my numerator stays 1. And I still have it squared. I have 3 2's, which means I can get out one group of 2's. I have 3 3's, which means I can get out one group of 3's. I have 3 x's, which means I can get out one group of x. And then nothing would be left in. So basically what I have is 1 over 6x squared. And then remember that that means I have to do 1 squared, 6 squared, and x squared. So 1 squared is 1, 6 squared is 36, x squared is x squared. So my ending answer would be 1 over 36 x squared. I'm going to see if I have room to fit one more problem right over here. It might get kind of squishy. 32 r squared to the 6/5. So we're going to go ahead and make that into radical form. In radical form, I don't know why I made that radical so big. The index of the radical is going to be the denominator of 5. The radicand is going to be my 32r squared. And then I'm going to take that 6 and make it a big power outside. Next thing I'm going to do is simplify inside my radical. So I'm going to take that 32 and break it down. 32 would be 4 times 8. 4 is 2 times 2. 8 is 2 times 4. So we have 2 times 2 times 2. And then 4 is 2 times 2. So 32 is the same thing as 2 to the 5th power. So now what I have is the 5th root of 2 to the 5th power times r squared, and then all to the 6th. Two to the 5th inside that index of 5. So index of 5 means need 5 in the group to get out. I have 5 2's, so I can bring a 2 out. I only have 2 r's, so my r squared has to stay in. And then the whole thing is to the 6th power. So I need to show you how to deal with that. Well, when we have multiplication, remember that the power has to go to all of the bases. So how we're going to apply that rule is that this 6 is going to apply to the 2. So that's going to give us 2 to the 6th power. And then the 6 is also going to apply to the r squared. So when we raise r squared to the 6th power, remember the rule for that is that we multiply the exponents. So I'm still going to have the 5th root, but now I have r to the 12th inside that 5th root. This gives me another opportunity to simplify. First thing I want to simplify is 2 to the 6th power. Well, I'm going to cheat a little bit. I already know 2 to the 5th power is 32. 2 to the 6th would be times 2 more, so that'll be 64. And then the 5th root means I need 5 to get out. I have 12 r's. Having 12 r's means that I would have 2 groups of 5, and then I would have 2 left over. So having 2 groups of r's that can get out, but leaving 2 r's left inside, gives me a final answer of 64r squared times the 5th root of r squared.